This is Math 1000, section 7.3. We are going to simplify all these radicals. For problem number 11, you have the square root of 24. So you're going to break 24 up into what numbers multiply to give you 24. So if you thought about a factor tree, 24, we have 3 times 8 is 24, and 2 times 2 times 2 is 8. So we have 3 2s and a 3. So if it's the index is 2, you're going to pull out one set of 2s and you have a 6 left. So your answer for this would be 2 root 6. The 2 comes out and what stays is that. So I'm going to go a little quicker here. 50 is 5 times 10. So 5 and then 10 is 2 times 5. So 5 times 10. So we have a pair of 5s. So the 5 comes out and then the 2 stays. 40. 40 is 4 times 10, and 4 is 2 times 2. 4 times 10, or you could say 8 times 5 is 40. So we are looking still for the square root, so that's it, a 2 comes out. So this would be 2 root 10. Number 23, cube root of 54. We are looking now for 3 of a kind. So we have 2 times 3 times 3 times 3 is 54, because 27 times 2 is 54. So we have 3 3s here, and there's our 3 of a kind. So our answer for this is 3 times the cube root of 2. Now 40, here are the numbers that multiply to give you 40, which were 2, 2, 2, and 5. So we have 3 2s here. So it's 2 times the cube root of 5. 31, we have -1, and then we're going to break up. We need 5 numbers that multiply to give you 64. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, 32, 64. So we're looking for 5. 1, 2, 3, 4, 5 of these 2's come out. What stays is that 2. So you're going to take this 2 and multiply it with that. So you end up with -2 times the 5th root of 2. Now we have some variables here. I would rewrite this as 6, rewrite it as 6 over 3. Now because that reduces to 2, that's your answer. The next one, we have a, the square root of a to the 5th power. So this is a to the 5 over 2. Now if you were to rewrite this as a mixed number, you get 2.5. So the a squared is what comes out, but what stays is the a to the 1/2. So it's the square root of a. B to the 23 over 4. Well, how many times does 23 go into 4? Well, 6 times 4 is 24. Well, how about 5? So we have 20 with 3 left over. So this mixed number is 5 3/4, because 4 times 5 is 20 with 3, so 3/4. So this is the whole part that comes out, b to the 5th, and what remains is the 4th root of b cubed. So the fractional part is what stays. Next one. 3 times y to the 23rd over 5. So I would rewrite this as a mixed number. This was 4 3/5. Now this 3 is just a regular 3, it's going to stay outside. So we have y to the 4th power. And then what stays is this 5th root of y cubed. Okay, next one. I'm going to work this way now. This one you're going to break up into 3 over 3 and y to the 7 over 3. Well, 3 over 3 reduces to 1. And this, if you made that a mixed number, this is going to be 2 1/3. So now, this is the whole part that stays out, but this fraction part, if you want to just change this, this is going to be the cube root of y. So you can write this as the cube root of your y that was left. Okay? The last 3, we are going to write, we have 24, and then we have x to the 15th, y to the 20th, and z to the 27th. So let's do 24 first. 24 breaks up into 2 times 2 times 2 times 3. So we're going to pull a 2 out, but what stays is the 6. Now you've got 15 over 2. So that is 7 1/2. So we have x to the 7, but we have 1 x left underneath the radical. Then we have y to the 20 over 2 power, which is a 10. So we have the whole y to the 10th comes out. And then we have z to the 27 over 2. And that would be, so how many times does 2 go into 27? That would be 13. That's 26. 1 left. So that would be z to the 13th with 1 z left over. Next, we've got 59. 59, we're looking for the 4th root. The 4th root says we are looking for 4 of a kind. I need 4 of the same number that's going to multiply to give you 32. So I'm going to use another piece of paper here because I'm running out of room. So I've got the 4th root of 32. So 32 is 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So there's 4 2's right there. So the 2 comes out, but this 2 stays. So I'm going to leave some room for these 3 letters. I have to leave some space. So I'm going to put the 4th root, this 2 doesn't have anything to do. Now I can do in my head 8 over 4. And 8 goes over 4 2 times, so I'm just going to write x squared. 9 over 4. Y 9 over 4. That is 2 1/4. So there's 2 full y's that come out, but 1 stays. And z to the 19 over 4. How many times does 4 go into 19? 4, 8, 12, 16. So that's 4 with 3 left over. So that would be z to the 4th power with 3 remaining. So that would be a 2 comes out, 2 x's come out, 2 y's come out, 4 z's come out, and these are all the stuff that doesn't have anything paired. So that's the answer to that one. So we have, for an answer, we have 2x squared y squared z to the 4th times the 4th root of 2yz cubed. And the last one, we have 32, and we just found out that 32, we're looking for 5 of a kind, and 32 is 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. We are taking all of our 2's out. Now, 10 goes over 5 2 times, so all of our a's come out, and 12 goes over 5 2 times. How many are left? 2. Two b's are left. Okay, now the next side are all division. If you can divide, if the indexes are the same, if they're both underneath the same index, then you can cancel. You can't cancel if you had something like, if I said, what's the cube root of 18 over the square root of 2? That, you don't have the right to cancel these two. This is a 3, this is a 2 index. You can't do that. But because these are under the same index of 2, and it could be like this too. You could have root 18, it could be broken up. This means the same thing. This means the same as that. So, in either case, whether it's written like this or written like this, you can cancel. 2 goes into 18 9 times, so really all you're doing is the square root of 9, which is 3. Same with this one. 3 goes into 27 9 times, square root of 9 is 3. You're going to reduce this. This is the cube root. 3 over 24 is 1/8. And the cube root of 1 is 1, and the cube root of 8 is 2. Next one, 77. Does 3 go into 48? It sure does. 16 times. And what's the 4th root of 1? 1. And what's the 4th root of 16? 2. This one, you could take the square root of x squared, which is x, and the square root of 9, which is 2, which is 3. This one, cube root of 6, c to the 6, so 6 over 3, which is 2, c squared. And what 3 numbers that are the same multiply to give you 64, and that would be 4. Next one, 3 goes into 24 8 times. Now, there's an understood 1 there. You don't need it. Now, what's the square root of 8? Well, that would be, we've got 2, 2, 2. So you pull the 1, 2 out, so you have 2 root 2. 93, this is nice because You can cancel, they're both square root. So think of it as a fraction. If you had this fraction, if you had 48 x to the 6th, y to the 9th, and then 6x squared y to the 6th like we had in the last chapter. 6 goes into 48, how many times? That would be 8. And then these two x's cancel with 2 here. And 6 of these y's cancel with 3 of them here. So you have y to the 3rd. So remember, you're still underneath one radical. But in the bottom, there's a 1 left. So on top, all you have is 8x to the 4th y cubed. So now, there's a 1 underneath, so that's just a 1. What do you have that's 2 of a kind that come out? You've got 3 2's here, so a 2 comes out, but a 2 stays, because you have 3 of them. 2 x's come out, 1 y comes out, but 1 y stays. Because remember, we have 3 y's here. You have y, y, y. So 2 of the 3 y's come out, 1 has to stay. Just like the 2's here. And 97. We're going to simplify this because they're both cube root, numerator and denominator. Here we go. 5 goes into 25 5 times. We've got 2 x's here, but we've got a lot here, so we've got an extra 6 at the bottom. And we've got an extra 7 y's at the top. So, looking for 3 sets of 3 of these numbers, I know that's the cube root. Cube root. I know that this 5 has to stay. But I know what could come out. 2 sets of x's could come out, so they wouldn't stay here, they would come out. And here I've got 7 y's, so 2 sets of y's would come out, but 1 y would stay. So technically what I have here is y squared. Actually I have a 3, not 3, that's the cube root. I have y squared times the cube root of 5y, and then you can have x squared. You can have it like that, or you can put it all over. It's up to you how you want to write this. You can write y squared over x squared times the cube root of 5y, or you can put that like that and then over x squared. Either way is fine. But this x to the 6, you can take 2 sets out, because 6 over 3 is 2. So 2 sets of y's come out, but the 5 has to stay, and that 1 leftover y has to stay. And it's in the numerator. And that concludes section 7.2.